Hi, my dear Tare Jaminpar. In our previous video, we discussed the concept of similarity with the help of daily life examples. Now, in this video, we are going to discuss examples of mathematical images or figures. I think you have already watched our video on basics of similar triangles. In that, we have discussed it with the help of daily life examples such as Reddy, Pinky, Amber and Damber. Now, let us take the examples of mathematics. Here you have on the screen two circular discs. These two are similar or not? Excellent. Your answer is correct. And what about these two? Very good. These two pairs are also similar because these two pairs are having same shape and all corresponding body parts are proportional. Now look at here. Do you think these two images are similar? No. Why? Because both of them are not having same shape. Now let us see few more images on the screen. Here one pair of squares are there. Here also one pair of squares are there. Do you think these are similar? Yes, the answer is yes. Why? Because these pairs are having same shape and their corresponding body parts are proportional. So now let us discuss little bit difficult examples. On the screen you have two rectangles. Do you think both of them are similar? Mostly with our visibility or visible capacity we can say these two rectangles are similar. Why? Because both of them are having same shape, one reason, and with our visible capacity we can say length and width of this small rectangle is increased here in the same ratio. So that is the reason we can say with our visible capacity these two rectangles are similar. I am mentioning visible capacity because here mathematical information is not there to calculate the ratio of corresponding parts. So that is the reason I am mentioning with our visible sense. We can say these two rectangles are similar. Let us now look at two more figures with mathematical information. See here you have two rectangles, big and small. Length of big rectangle is 8. Length of small rectangle is 4. 8 by 2 you will get 4. Let us talk about width. Width of this big rectangle 4. Width of this small rectangle 2. Half of this 4 is equal to 2. The conclusion is length and breadth are decreasing in the same ratio in the small rectangle. I mean length of this rectangle, small rectangle is half of this big rectangle. Breadth of this small rectangle is also half of this big rectangle. From this what we can conclude is length and breadth of these two rectangles are in the same ratio. Since corresponding body parts of these two rectangles are in the same ratio and all the angles are also equal in these two figures, that is the reason we can say these two figures as similar. So finally we can say yes, these two are similar. Now observe two more figures. Here in small rectangle length is 4. 4 into 2 8 you will get. But here when you observe width 2 into 2 you should get 4, but you have 10 centimeters. So it may be any angle you observe. The corresponding body parts or corresponding sides of these two rectangles are not neither increasing nor decreasing in the same ratio. Since corresponding body parts are not proportional, we can say these two rectangles are not similar. Hope you got good clarity on what we are trying to discuss. The conclusion of all these examples is if two polygons are having same angle and all the body parts are proportional, then we can say those two polygons are similar. Finally, the conclusion is if two polygons, it may be rectangle or triangle, square, it may be anything, any two polygons of same shape, if their corresponding body parts or if their corresponding sides are proportional, then we can say those two polygons are similar. In the next video, we will be discussing about only triangles and their similarity. Till then, bye. Have a nice day.